Hello again with a new video related to forces and objects moving on an inclined surface. Now we have the scenario here asking about what is the coefficient of a friction of an object moving. That's mean here we're asking for the mu k because it is the kinetic friction coefficient down a 35 degrees slope at a constant speed of 12 meter per second. Okay, let's try to sketch it. That's the angle, that's our object here. Now we have forces, we know it is the mg, which is going to be analyzed into two components, mg cosine theta, that's the perpendicular one, that's the parallel one, mg sine theta. We have also the normal force, which will be perpendicular on the surface. And finally, we have the friction, which is going to be opposite to our motion. That's the kinetic friction force. Okay, now the keywords we managed to figure out, because it's moving, that means we're asking for the kinematic friction coefficients 1. And now giving us some other information, the angle, the speed, to find that. Now simply we're going to follow Newton's law, total forces equal ma. Now what forces we have? Mg sine theta, that's the parallel component of the weight, minus the kinetic friction force, and equal ma. Now saying constant speed means that there is no acceleration, which means this part is equal 0. From here we can say that mg sine theta will equal the kinematic friction force, and we know this one equal friction coefficients multiplied with the normal force sine theta. Now we did that many times before, but it's not gonna hurt to find how much is the normal force. We know the total forces in the y-axis will equal 0 because there is no motion. And what forces on the y-axis will be normal force minus the perpendicular component of the weight. From here, the normal force equal mg cosine theta. So let's take this and put it into our equation. So mg sine theta will equal uk mg cosine theta. Once again, I have mass times the gravity acceleration. I can eliminate them. Now we can find how much is this coefficient simply by saying sine theta over cosine theta, and this is exactly the tan of our angle, which is already been given from the start, tan 35. So let's find how much is the tan of 35. It will equal 0.7. That's the coefficient or the kinematic coefficients of a friction for this surface. Okay, this is one example. I will include another example in this video, which is here. I have a boy is pulling a 6 kg sled up a hill at a constant speed of 6 meters per second. The hill has a slope of 38 degrees and the coefficient of a friction 0.2. Again, it's moving, so this is the kinematic friction coefficients. Determine the force applied by the boy in order to move the sled up the slope at a constant speed. Assume the boy pulls with a force parallel to the inclined plane. So let's once again do our sketch and see how is that going to help us. So that's the horizontal, that's our incline. This is the angle, which is 38 degrees. So let's assume this is the sled. It's quite a big box. Doesn't matter here. okay, as our sled. Okay. Now we know that there are certain forces at start. Once again, this is the weight, that is mg cosine theta. It's the parallel one, mg sine theta. We have the normal force, it's perpendicular on our surface. And now the boy is pulling up, so this child or this boy is pushing parallel, as we said here. It's the force or the applied force, it's parallel to the incline, so I'll call this the force applied, which means the friction will be the opposite of our motion as the kinetic friction force. Okay, these all the forces acting on this sled. So this is our free body diagram. Now we can start doing our calculation. Now the total forces on the x-axis will equal the mass times acceleration. However, it says here that the boy is moving in a constant speed, which means this part, as we discussed before or earlier in this video, equals 0. Here, what forces we have? I will have the applied force minus mg sine theta, the parallel component of the weight, minus the kinetic friction force, that all equal 0. Now we know that the friction force, it's equal mu k Fn, and we did that just before or earlier in this video and many other videos before. We used the y-axis to calculate that. So from here I can find this applied force, which equal mg sine theta plus the kinetic friction force. So let's put all together as mg plus uk, which is already here, it's 0.2, and mg cosine theta. Now simply you could take the mass times the gravity acceleration as a common factor and do your calculation. Let's do it, it's fine. Now just by doing the calculation on our calculator, that will give us 45.5 Newton. This is how much force this boy applied to move the sled up the hill or on this slope. Okay, I hope you found this video useful, and I'll see you again with another one. Thank you.